Hello my dear students, my name is Lakshmi. This is LN brand of chemistry channel. So today we are going to discuss about electrolytic conductance. In the previous session we are discussed about the Faraday's laws of electrolysis. So previous video Faraday's laws of electrolysis will be there. So this is lecture number 8. So that is electrolytic conductance. Electrolytic conductance. Electrolytic conductance. Students, before going to discuss about the electrolytic conductance, sir, first of all, what is the conductor? So that we have to discuss. Sir, conductor ante enti? So it is not a bus conductor or like that. It is not like. So conductor in electrochemistry. Sir, conductor, that is, a conductor means the substance which allow electricity through in it. A substance which allow electricity through in it is called as conductor. The substance which allows electric current through in it are called conductors. So conductors are two types. Conductors are how many types? Two types. What are those? So conductors are two types. What are those? Conductors are two types. What are those? One is metallic conductor. Sir, one more, electrolytic conductor. So metallic conductor is also called as electronic conductor. Clear? Sir, here in the name itself it is there, metallic conductor, metal will be present. So for example, for that iron, then silver, then copper, then aluminum. So all these are electronic conductors of the examples for electronic conductors. Then what about the electrolytic conductors? Electrolytic conductors ke example enti? Sir, example for the electrolytic conductors are, sir, aqueous NaCl solution, then aqueous NaOH solution, so then fused NaCl solution, so like this present. So this is electrolytic conductors. So these are the differences between the electronic conductors and as well as electrolytic conductors. So now we have to discuss about the differences between metallic conductors and electrolytic conductors. Nothing but electronic conductors and electrolytic conductors. The differences we have to see. So what are the differences will be there in between electronic conductors and electrolytic conductors? First one, electronic conductors. Then electrolytic conductors. Electronic conductors and electrolytic conductors. So electronic conductors means I told that the examples are copper, silver, then aluminum, all these are the examples. Then electrolytic conductors, what I told, aqueous solutions of NaCl, KCl, NaOH. So like this, all these examples. Okay. Sir, here one of the thing you have to observe that, sir, electronic conductors are due to the flow of electrons, electricity will be passed. So due to the flow of electrons, so what I told, due to the current flow, due to the presence of, or due to the flow of electrons, current flow due to flow of electrons. This is current due to flow of free ions. So this is the main that is fundamental point in the electronic conductors and electrolytic conductors. Then in case if you take the second point, no chemical change or no chemical decomposition occurs by passing electric current. Are you getting my point? Sir, for example, మనం వైర్ కరెంట్ లైట్ వైర్ చూస్తాం. సార్ అందులో ఎలక్ట్రిసిటీ పాస్ అవుతూ ఉంటుంది. Is there any chemical changes in it? No chemical changes are occur in metallic conductors. By passing electric current. But here chemical decomposition occurs. Chemical decomposition occurs by passing electric current. Sir, how sir idela? For example, NaCl will be there. It can be dissociated into Na plus Cl minus. ఒక కాంపౌండ్ డిసోసియేట్ అవుతుంది. So by passing electricity, so that's what chemical decomposition we call. Chemical decomposition. So then here conductivity, in case if you take, conductivity is very high. But here conductivity is relatively low. Conductivity is relatively low in the electrolytic conductors. Here, due to the presence of free electrons, and then one more, there is no any chemical decomposition occurs in the reactions. So that's what here the conductivity is very high. There conductivity is relatively low. So then here resistance increases. Sir, what is the resistance, sir? Resistance increases when temperature increases. Right? Sir, what is the resistance? Resistance nothing but opposing force of the current. కరెంట్ వస్తూ ఉంటే కరెంట్ను అపోజ్ చేయడాన్నే మనం రెసిస్టెన్స్ అంటాం. ఓకే సార్, రెసిస్టెన్స్ అనేది మెటాలిక్ కండక్టర్లో లేదా ఎలక్ట్రానిక్ కండక్టర్లో టెంపరేచర్ పెరుగుతూ ఉంటే రెసిస్టెన్స్ పెరుగుతూ ఉంటుంది. రెసిస్టెన్స్ పెరుగుతూ ఉంది అంటే దాని మీనింగ్ కండక్టెన్స్ తగ్గుతూ ఉంటుంది. సార్, వాట్ ఈస్ కండక్టెన్స్ ఆర్ డిక్రీజెస్? Conductance is decreases. Understand, my dear students? Then in this, where in the electrolytic conductors, resistance decreases. Resistance decreases by increasing temperature. టెంపరేచర్ ఇంక్రీజ్ చేస్తూ ఉంటే రెసిస్టెన్స్ తగ్గుతూ వస్తుంది. దెన్ ఏది ఇంక్రీజ్ అవుతుంది? సార్, కండక్టెన్స్ ఇంక్రీజ్ అవుతుంది. కండక్టెన్స్ ఈజ్ ఇంక్రీజెస్ బై ఇంక్రీజింగ్ ద టెంపరేచర్ ఇన్ ఎలక్ట్రోలైటిక్ సెల్స్. But conductance is decreases in the electronic conductors by increasing temperature. Understand, my dear students? So these are the two differences in between the electronic conductors and electrolytic conductors. So next, what are the useful terms are required for the to discuss about the electrolytic conductance? That we have to discuss. ఎలక్ట్రోలైటిక్ కండక్టెన్స్ను డిస్కస్ చేయడానికి ఏమేమి యూజ్ఫుల్ టర్మ్స్ కావాలో సార్ ఆ టర్మ్స్ను మనం ఇక్కడ డిస్కస్ చేస్తూ ఉన్నాం. సార్ ఫస్ట్ వన్ దట్ ఈస్ రెసిస్టెన్స్. సార్ ఇక్కడ వచ్చింది మనకు రెసిస్టెన్స్ అంటే ఏంటి అని అడిగారు. రెసిస్టెన్స్ అంటే అపోజింగ్ ఫోర్స్ ఆఫ్ ది కరెంట్. రెసిస్టెన్స్ నథింగ్ బట్ రెసిస్టెన్స్. దీన్ని దేంతో రిప్రజెంట్ చేస్తాం? క్యాపిటల్ ఆర్ తో రిప్రజెంట్ చేస్తాం. నథింగ్ బట్ అపోజింగ్ ఫోర్స్ ఆఫ్ current. Opposing force of current. Sir, what are the units of resistance, sir? Sir, units for the resistance is then ohms. దీన్ని ఇలా సింబల్ తో కూడా రిప్రజెంట్ చేస్తాం, ఓమ్స్. ఓకే, అండర్స్టాండ్ మై డియర్ స్టూడెంట్స్? దట్ ఈస్ రెసిస్టెన్స్. దెన్ నెక్స్ట్ వన్ కండక్టెన్స్. Sir, conductance nothing but that we have to represent with a C. Conductance nothing but electric current. When it is flow through the electrons or when it is flow through the ions, that we are calling the conductance. Sir, conductance C is inversely proportional to the resistance. So that's what we call, when we are discussing about the conductance, reciprocal of resistance is called as conductance. We call reciprocal of resistance. ఏమంటుందని? Reciprocal of resistance. Sir, what are the units for this, sir? Sir, units, sir, when R is there, then we call it as a ohm. 1 by R, then ohm inverse. What we call? The ohm inverse, or otherwise, so symbol we have to represent like this. Sir, ఈ ohm inverse నే sir mo అని కూడా అనొచ్చు. mo opposite. Clear, my dear students? So two terms we are discussed. One is resistance, the one more conductance. Then third one is specific resistance. దీన్నే resistivity we call. Resistivity, specific resistance or resistivity, that we have to represent with a rho to represent చేస్తాం. Okay, right. Sir, what is the resistivity అంటే ఏంటి? So here first, so one of the formula you must be know in case if you want to know about the resistivity. So that is R, it is equals to rho into L by A. This is the formula. R equals to rho into L by A. This is the formula. Sir, ఏంటి సార్ ఇది? Resistance of any substance is directly proportional to the length of, sir, in case if you take, it is one of the metallic conductor. This is we are calling area of cross section. That we have to represent with a capital A. Area of cross section. Then from here to here we are calling it as a length, L. So length of the substance. Clear? Right. So now I told for any substance like this. So I told that resistance of the substance is directly proportional to length of the substance and inversely proportional to area of area of cross section. Cross section. Are you getting my point? So length is directly proportional, area of cross section is inversely proportional. So that means, so this area of cross section nothing but so దాని మందం వైర్ యొక్క మందం ఆ రాడ్ యొక్క మందం పెరిగితే దెన్ కండక్టెన్స్ తగ్గుతుంది, సో రెసిస్టెన్స్ తగ్గుతుంది. ఏం తగ్గుతుంది? రెసిస్టెన్స్ తగ్గుతుంది. సో దట్స్ వాట్. ఇది రెసిస్టెన్స్కి ఇన్వర్స్లీ ప్రపోర్షనల్లో ఉంది, ఇది రెసిస్టెన్స్కి డైరెక్ట్లీ ప్రపోర్షనల్లో ఉంది. రెండింటిని యాడ్ చేసే రెసిస్టెన్స్ ఇస్ డైరెక్ట్లీ ప్రపోర్షనల్ టు లెంత్, ఇన్వర్స్లీ ప్రపోర్షనల్ టు ఏరియా. దెన్ వీఆర్ టేకింగ్ it is what? Resistivity. That is one of the constant value. Understand, my dear students? Right. So now, okay, we are discussed about the length, area of cross section, all these things we are discussing. So length, area of cross section we are seen in the metallic conductors. Metallic conductors lo gurinchi manam discuss chesam. Sir, in case electrolytic conductor will be there, sir, how can you see that area of cross section? What we have to see? Then length, what we have to see? That we'll discuss now. Sir, up to here, note it clearly. If you have any doubt, ask to me. Right. Yes, come to the point. I told that, sir, we are seeing the resistance and length area of electronic conductors. అంటే మెటల్కి అయితే లేదా మెటల్ రాడ్కి అయితే దాని రెసిస్టెన్స్ ఎంత ఉంది, దాని లెంత్ ఏంటి, ఏరియా ఏంటి ఫైండ్ అవుట్ చేయొచ్చు కదా. సరే, ఇన్ కేస్ ఇఫ్ యూ టేక్ దిస్ ఇస్ ద లెంత్, దెన్ ఇట్ ఈస్ ఎల్, దెన్ వీ కాల్ ఇట్ ఇస్ ద ఏరియా ఆఫ్ క్రాస్ సెక్షన్ ఏ, రైట్. సరే, వైర్కి అయితే. బట్ వాట్ అబౌట్ ద ఎలక్ట్రోలైటిక్ కండక్టర్స్? ద ఎలక్ట్రోలైటిక్ సెల్ తీసుకున్నప్పుడు, సరే ఎలక్ట్రోలైటిక్ సెల్ తీసుకున్నాం, ఎలక్ట్రోలైటిక్ సెల్. సరే, వాట్ we are discussing? area, that is A, and length for electrolytic cell. Electrolytic cell ki area, length of the unit cell, that we have to discuss. సరే, ఇక్కడ 2 ఎలక్ట్రోడ్స్ ఉన్నాయి. ఒకటి యానోడ్ గా వర్క్ చేస్తా ఉంది, ఇంకొకటి క్యాథోడ్ గా వర్క్ చేస్తా ఉంది. సరే, ఇందులో ఎలక్ట్రోలైటిక్ సొల్యూషన్ కూడా ఉంది. దీన్ని electrolytic cell or conducting cell we call. Electrolytic cell అంటాం. ఓకే సార్, ఎలక్ట్రోలైటిక్ సెల్. ఇందులో సరే ఏరియా ఆఫ్ క్రాస్ సెక్షన్ యూ హ్యావ్ టు టేక్ ఫర్ ద ఎలక్ట్రోడ్స్కి తీసుకున్నప్పుడు దాన్ని ఏరియా ఆఫ్ క్రాస్ సెక్షన్. సరే, ఎలక్ట్రోడ్ యొక్క ఏరియా ఆఫ్ క్రాస్ సెక్షన్. Then length, in case if you take length, sir, length, so from here to here, ante, so length we have to take the distance between the 2 electrodes. Length, that is distance between 2 electrodes. Distance between the 2 electrodes is called as the length. Understand, my dear students? Okay, whatever it may be. Then, sir, R is directly proportional to length and inversely proportional to area of cross section. Even for electrolytic cells also, the same formula we have to use. Okay, clear? Sir, here I told that in case length it is equals to 1 centimeter will be there. Then area it is equals to 1 centimeter square will be there. Area 1 centimeter, even length also 1 centimeter, area 1 centimeter square, length 1 centimeter, that will be there. Then, sir, actually we have to get it is the resistivity, right? Then resistivity it is equals to then R into A divided by L. R into A divided by L. Then from this, sir, R into, sir, area 1, then length 1, so then both will be cancelled. Then resistivity equals to resistance. Resistivity equals to resistance. Sir, when resistivity equals to resistance, resistance is offered by all the ions are present in within the 1 centimeter cube of electrolytic solution. Sir, how it is, sir? So look at, sir, in case area 1 centimeter square we are taken, then length 1 centimeter we are taken, then volume of this solution, volume of that electrolyte, how much? 1 centimeter cube. 1 centimeter cube. అంటే అదేలా సార్ 1 సెంటీమీటర్ క్యూబ్ అంటే, సో ఒకసారి చూడండి. సో లుక్ ఎట్ దిస్ ఈజ్ ఏరియా ఆఫ్ ఎలక్ట్రోడ్, దెన్ దిస్ ఈజ్ వన్ మోర్ ఎలక్ట్రోడ్, వన్ ఈజ్ యానోడ్, వన్ ఈజ్ క్యాథోడ్, రెండు ఉన్నాయి. సో దిస్ ఈజ్ వన్ ఎలక్ట్రోడ్ అండ్ దిస్ ఈజ్ అనదర్ ఎలక్ట్రోడ్. ఇన్ బిట్వీన్ దెమ్ డిస్టెన్స్ విల్ బి దేర్ 1 సెంటీమీటర్, 1 సెంటీమీటర్ డిస్టెన్స్ ఉంది. సరే ఇది 1 సెంటీమీటర్, then ఇది 1 centimeter, then area of each electrode 1 centimeter square. Then in between the two electrodes, whatever the solution is there, in between the two electrodes, whatever the solution is there, so totally that is we are calling the volume. So volume equals to area into L. So area 1 centimeter square, then length 1 centimeter, then you can get it is 1 centimeter cube, 1 centimeter. So within the 1 centimeter cube, how many ions are there? All the ions of the resistance of that we call it is resistivity or specific resistance. So what is the definition for specific resistance? Specific resistance or resistivity. స్పెసిఫిక్ రెసిస్టెన్స్ ఆర్ రెసిస్టివిటీ ఎలా డిఫైన్ చేస్తాం, ఆర్ని ఎలా డిఫైన్ చేస్తా ఉన్నామంటే, ఆల్ అయాన్స్, సో దట్ ఈస్ రెసిస్టెన్స్ ఆఫర్డ్ బై ఆఫర్డ్ బై all ions present in 1 centimeter cube of, look at 1 centimeter cube of 1 centimeter cube of an electrolyte. 1 centimeter cube of an electrolyte is called as resistivity. Understand, my dear students? Right. So resistivity, the formula of this. So within the 1 centimeter cube, nothing but you have to take area 1, length 1, then you can get the resistance, that is resistivity. Understand? So here units, in case if you take units kanaka తీసుకుంటే, so units for this, tell me you only units. So resistance units I told that ohms, then area centimeter square, then this is centimeter. So units you can take it as ohms, then centimeter you can take centimeter, ohms into centimeter, because centimeter square, then centimeter cancel, then ohms and centimeter you can get. These are the units. Clear, my dear students? Yes, just note it, that we'll discuss next terminology which is required for this. Okay, yes. So next we have to discuss about specific conductance. Sir, what is the specific conductance? Specific conductance ante enti? Reciprocal of resistance is called as, reciprocal of resistivity is called as, not resistance. Okay, so ఏమంటున్నాం, specific conductance. Specific conductance are conductivity, that we have to represent with the K, kappa we call, kappa, K nothing but kappa here. Sir, what is the specific conductance? Reciprocal of resistivity. resistivity. Reciprocal of resistivity, that is called. Ante so specific conductance we have to represent with a K. So K equals to 1 by rho. 1 by rho. So rho nothing but what we are taken. So 1 divided by rho nothing but now only we have seen. So that is R into A divided by L. Right. Then it will go up. L will go up. Then so 1 by R into L by A. 1 by R into L by A. This is the specific conductance or conductivity. Specific conductance or conductivity. Sir, what is this? Sir, what we are discussed about it? Sir, here that is conductivity. How can you define actually? Sir, conductivity we can define the reciprocal of the resistance. The conductance due to the all ions present in within the 1 centimeter cube is called as specific conductance. సో ఇంతకుముందుకు రెసిస్టివిటీ ఎలా అయితే డిఫైన్ చేశామో కండక్టివిటీ ఎలా డిఫైన్ చేస్తాం. సరే ఎలా డిఫైన్ చేస్తాం? అక్కడ రెసిస్టివిటీ గురించి రెసిస్టెన్స్ గురించి మాట్లాడాం, ఇక్కడ కండక్టెన్స్ గురించి మాట్లాడతాం. సో డెఫినేషన్ యూ కెన్ సే దట్ కండక్టెన్స్ ఆఫ్ all ions present in 1 centimeter cube of electrolytic solution. Electrolytic solution is called as, that is specific conductance. What we are calling specific conductor. So here, sir, L equals to, in case 1 centimeter, then A equals to 1 centimeter square, then L, then A, sir, both will be cancelled. That position we call it is a cell constant. Sir, cell constant rendu same అయినప్పుడు అది కాన్స్టెంట్ గా ఉంటుంది, that we call it the cell constant. So L by A we have to call it is a cell constant. Then 1 by R we have seen already, that is a conductance. So K nothing but the K it is equals to, that is 1 by R nothing but conductance. Then L by A nothing but cell constant. Like this also we can define the conductivity. That is conductivity or specific conductance. Understand, my dear students? Then what are the units of this? Is units enti? Units ki specific conductance leda conductivity ki units enti? Sir, I told that K it is equals to, what I told, 1 by R into L by A, right? Yes, sir, right. 1 by R, that is ohm inverse. Then L by A, sir, L centimeters, so A centimeter square, centimeter inverse. What we call centimeter inverse. Sir, ohm inverse ni sir ila kuda rayachu. Sir, Simon, SIE, yes nothing but that is SIEMEN, Simon. I think so. SEI, sorry. SEI, Simon, SEI, that is S dot centimeter inverse. అంటే ఓమ్ ఇన్వర్స్ ని సీమన్ అని కూడా అనొచ్చు. ఎస్, క్లియర్ మై డియర్ స్టూడెంట్స్? సో దీస్ ఆర్ ద యూనిట్స్ ఫర్ కండక్టివిటీ. సో ఆల్ ది యూనిట్స్ యూ హ్యావ్ టు నోట్ ఇట్ and keep in the mind is very, very, very important in the calculations. Okay, clear? Yes, note it. Next we'll discuss next one. So this is the fourth term we are discussing. Then the fifth one, that is molar conductance. Have to discuss. Molar conductance. Sir, what is the molar conductance? That we have to discuss. Molar conductance ante enti? Sir, molar conductance ante same like specific conductance, but here 1 mole of electrolyte should take but not in 1 centimeter cube of the electrolyte. Okay, so that is molar conductance. Molar conductance. So how can you represent the molar conductance? This is the molar conductance. Molar conductance. ఎలా రిప్రజెంట్ చేసాం molar conductance ని? delta m తో రిప్రజెంట్ చేసాం. So how can you define the molar conductance? Sir, conductance due to all ions. Conductance due to all ions present in a volume of 1 mole of electrolyte, that is called molar conductance. So molar conductance ante that I say all ions present in 1 volume of 1 mole of an electrolyte, that is. So we can say that is the conductivity. So for example, in case if you take it is electrolytic cell. So conductivity within the centimeter cube you will see. Within the centimeter cube లో కనుక చూస్తే దాన్ని మనం కండక్టివిటీ అంటాం. అంటే కప్ప నథింగ్ బట్ కండక్టివిటీ. కానీ మోలార్ కండక్టెన్స్ ఏమంటున్నాడు? సార్ వాల్యూమ్ నాట్ మెన్షనింగ్. సార్ వాల్యూమ్ అది ఎంతైనా కావచ్చు, బట్ ద సొల్యూషన్ కాన్సన్ట్రేషన్ షుడ్ బి 1 mole అయి ఉండాలి, 1 molarity అయి ఉండాలి. Then we call it is molar conductance. Clear, my dear students? Right. So that's what I told. Molar conductance, it is equals to K. K ante sir conductivity ga sir, of course conductivity within the centimeter cube, into V, total volume. In case if you take total volume, K into V. Okay, understand? Right. So K into V అని తీసుకోవచ్చు molar conductance ni అని చెప్తాం. Okay sir, right, understand sir. So now sir V from the molarity, in case if you take molarity equals to number of moles into 1000 divided by sir volume in milliliters and formula. Sir milliliters nothing but centimeter cube only. Are you getting? Yes. Sir in case n equals to 1 mole, n 1 mole అయినప్పుడు then molarity equals to, you can get it is 1000 divided by then volume in milliliters, right? Volume in milliliters. Then volume is required here. The volume nothing but volume in the milliliters nothing but what you can take? That is 1000 divided by molarity, right? 1000 divided by molarity. So in the place of this, the molar conductance is equals to K into 1000 divided by molarity have to take for the molar conductance formula. Sir, what are the units, sir? So units, in case if you take units, then conductivity, what we are taking the conductivity? Sir, ohm inverse, then centimeter inverse, sir. Right or not? దాన్ని సరే ఇంకో రకంగా ఏం చెప్పాను? Siemen, then centimeter inverse. So then divided by, so 1000 के units same, then molarity units ఏంటి? మోల్ పర్ లీటర్. బట్ ఇక్కడ లీటర్లో తీసుకోవట్లేదుగా, సెంటీమీటర్ క్యూబ్లో తీసుకుంటున్నాం బికాస్ ఆఫ్ ది మిల్లీ లీటర్స్. వాల్యూమ్ ఎక్కడ తీసుకున్నాం? మిల్లీ లీటర్స్లో తీసుకున్నాం. సో దట్స్ వాట్ సర్ హియర్ వీఆర్ టేకింగ్ మోల్, సో డివైడెడ్ బై ద సెంటీమీటర్ క్యూబ్. దెన్ యూ కెన్ గెట్ వాట్? ఎస్ centimeter square mole inverse. So these are the units for molar conductance. Understand, my dear students? So these are the units for molar conductance. So next one more. This is the fifth terminology which are the important terms I told you. Important terms ఏవైతే చెప్పానో అందులో ఫిఫ్త్ టర్మ్ ఇది. దెన్ సిక్స్త్ టర్మ్ మనం డిస్కస్ చేయాలి. దట్ ఈజ్ ఈక్వివాలెంట్ కండక్టెన్స్. సిక్స్త్ టర్మ్నే మనం ఏమంటున్నాం? ఈక్వివాలెంట్ కండక్టెన్స్. సరే, ఈక్వివాలెంట్ కండక్టెన్స్. సో దట్ ఈస్ వాట్? ఈక్వివాలెంట్ కండక్టెన్స్. Equivalent conductance. Sir, delta E, you have to take delta E. So then a definition, how can you say the definition? Conductance due to the all ions present in a volume of, in the place of 1 mole, you have to take 1 gram equivalence. 1 gram equivalence, 1 gram equivalence of electrolyte. Sir, what about the normality, sir? Sir, here the place of molarity you have to take normality, the same formula. The place of molarity you have to take the normality, that's it. Normality, but in the place of N, what we are taking? Gram equivalence, equivalence into 1000 divided by volume liters. So when equivalence equals to 1 equivalent, then in the place of that, so normality equals to 1000 divided by volume. So then volume, it is equals to 1000 divided by normality, right? So in the place of that, we have substituted there. So here if you come, so in the place of normality units, then equivalent divided by centimeter cube you are seeing. So then Siemen, then centimeter square, then mole inverse, in the place of mole inverse, so equivalent inverse you can get. So this is equivalent conductance. So molar conductance and equivalent conductance almost same, but in the place of just molarity we are keeping, that is normality, that's it. Okay, understand my dear students? Then we have to discuss about the relation between the molar conductance and equivalent conductance. So molar conductance ki equivalent conductance ki relation enti, that we have to discuss. What is the relation between molar conductance and equivalent conductance? Molar conductance ante enti, equivalent conductance ante enti? Relation between molar conductance and equivalent conductance. Equivalent conductance. Sir, molar conductance formula em తీసుకున్నాం sir? So delta M, it is equals to K into 1000 divided by molarity. Then equivalent conductance em తీసుకున్నాం sir? That is K into 1000 divided by normality. We are taken, right? So now the ratio of molar conductance and ratio that is equivalent conductance is equals to, then K into 1000 divided by molarity, sir, into, then sir, N divided by K into 1000, you can get, right? So K into 1000, the K into 1000 both will be cancelled. Then you can get the normality divided by molarity. So normality formula is what? Normality formula is, so that is gram equivalence divided by, so normality, so gram equivalence are divided by, so you can take it as, sir, volume in liters. Then here molarity, number of moles divided by volume in liters. So volume in liters cancel. Are you getting my point? Volume in liters cancel. Then what you can get? Then gram equivalence divided by number of moles. Then again, sir, gram equivalence, how can you get? Given weight divided by gram equivalent weight. The number of moles, how can you get? Given weight divided by gram molecular weight. So given weight cancel. Then you can get gram molecular weight divided by gram equivalent weight. Then gram equivalent weight nothing but gram molecular weight divided by gram equivalent weight nothing but gram molecular weight divided by then n factor. So now n factor will go up, then molecular weight cancel. The finally you can get it is molar conductance divided by equivalent conductance is equals to n factor. Sir, n factor ante enti sir? Sir, n factor is differ for different substances. N factor for acids, in case if we take acids, that is basicity. Ante number of H plus ions, number of H plus ions are replaceable. Then n factor for bases, sir. N factor for bases, it is equals to number of OH minus ions. Then n factor for salt, sir. Sir, n factor for salt equals to charge of cation or anion. Charge of cation or anion. So this is the relation between molar conductance and equivalent conductance. Yes, look here, my dear students. One of the question is there. The molar conductivity of a solution is 1.26 into 10 to the power of 2. Then ohm inverse, centimeter square, mole inverse. Then its molarity is 0.01. Then specific conductivity will be, they're asking question like this. Sir, what they're asking? Specific conductivity. The molar conductance formula, molar conductivity formula, sir, K into 1000 divided by, that is molarity, right? Then what they are given, molar conductivity is given 1.26 into 10 to the power of 2, then equals to K that you have to find out into 1000, 10 to the power of 3 and raskochu. Then molarity what will be there? The 10 to the power of minus 2 is there. Clear, my dear students, right? So now what do you want? Then K is required. So K is equals to then 1.26 into 10 to the power of 2 into 10 to the power of minus 2, then divided by, so 10 to the power of 3. So 10 to the power of 2, 10 to the power of minus 2 cancel. Then you can get it is 1.26 into 10 to the power of minus 3. So that is K conductivity. The conductivity formula that units ohm inverse, then centimeter inverse. So 1.26 into 10 to the power of minus 3, where will be there? So this is the answer for this. Understand? Then we'll see one more question based on it. Yes, note it. Note change one more question. One more question based on the molar conductivity and equivalent conductivity, as well as whatever we are discussing now. For an electrolytic solution of, for an electrolytic solution of 0.05 moles per liter or liter inverse, the conductivity has been found to be, the conductivity nothing but kappa, conductivity has been found to be 0.0110 Siemens centimeter inverse. The molar conductivity they are given options 0.055, then 550, then 0.22, then 220. So these are the options are given. So look, my dear students, what they are given, the conductivity is given, then molarity also is mentioned. So molar conductivity you have to find it. So we know the direct formula that molar conductivity is equals to then K into 1000 divided by molarity, right? Sir, K what will be there? Sir, K, so this is 0.001110 like this will be there. So when point is shifted to there, then 11 into 10 to the power of minus 3 can write. Then 10 to the power of 3 divided by molarity 5 into 10 to the power of what? 5 into 10 to the power of minus 2. Then here 10 to the power of minus 3, 10 to the power of plus 3 cancel. Then 11 divided by 5, then 2.2 into 10 to the power of minus 2 when it is go up 10 to the power of 2, nothing but 100, then equals to 220. 220 is the answer for this. So that is the D option is correct answer. Understand, my dear students? So such type of questions they are asking. Then based on it, one more question we'll see. Sir, one more question. That is the specific conductance of 0.1 normality KCl solution. The specific conductance of 0.1 normality of KCl solution at 23 degrees Celsius is then 0.012, then ohm inverse, then centimeter inverse. The K value is given. The normality is also mentioned. The resistance of cell containing the resistance of a cell, it is equals to 55 ohms are given. 55 ohms. Then find cell constant. Find చేయమని అడిగాడు. Sir, options are given, that is 0.124, 0.142, so then 0.66, then 0.918, then 1.12, like this is given. So B, then C, then D, options are given like this. So what you have to find out, then there is no any molar conductance or there is no any even equivalent conductance, but the specific conductance is given K. So K is given, resistance is given, the K and resistance and cell constant. So K 1 by R into L by A is the formula. ఈ L by A అనేది cell constant. So దాన్ని find out చేయాలి, cell constant find out చేయాలి. So that L by A, it is equals to K into R, right? Sir, K value what will be there? That means conductivity value 0.02, nothing but 12 into 10 to the power of minus 3 can take. Clear? Then, sir, resistivity what will be there? The 50 ohms or 55 ohms? 55. So 55, when it is multiplied with a 55, then you can get it as 660. 12 into 55. So, then 10 to the power of minus 3, then when it is multiplied, that 0.660. So 0.66, that is the answer for this. Okay, my dear students. Then one more question will be there. So this is noted, then we'll discuss one more question. Yeah, look here, one more question is there. That is resistance of conductivity cell filled with concentration 0.1 molarity is 100 ohms. The conductivity of this solution is 1.29 Siemens meter inverse. The resistance of the same cell when it is filled with 0.02 molarity of the same solution is 520 ohms. అంటే ఇక్కడ 2 రెసిస్టెన్స్ ఉన్నాయి, 2 మొలారిటీస్ ఉన్నాయి. సార్ ఒక సెల్ని 2 డిఫరెంట్ మొలారిటీ ఆఫ్ సొల్యూషన్తో ఫిల్ చేశారు. సార్ ఫస్ట్ మొలారిటీ దట్ ఈస్ 0.1 మొలారిటీ, అప్పుడు దాని రెసిస్టెన్స్ 100. 100 ohms. Then conductivity is given, K it is equals to 1.29, that is Siemens meter inverse అని ఇచ్చారు. Clear my dear students? Yes, you have to observe. Then so one more thing, sir, molarity of other solution 0.02 molarity of same solution, molarity change, that's it. అప్పుడు దాని రెసిస్టెన్స్ 520 అయింది, రైట్. దెన్ ఇప్పుడు మోలార్ కండక్టెన్స్ ఫైండ్ అవుట్ చేయమని అడిగాడు. మోలార్ కండక్టెన్స్ ఫైండ్ అవుట్. సరే మనకు మోలార్ కండక్టెన్స్ దీని సొల్యూషన్ది ఫైండ్ అవుట్ చేయాలి అంటే దెన్ ఫార్ములా ఈజ్ K into 1000 డివైడెడ్ బై దెన్ మొలారిటీ హౌ టు టేక్, రైట్. సార్ K ఇక్కడ లేదు కదా, సార్ K ఫైండ్ అవుట్ చేయాలి దీన్ని ఫస్ట్. సార్ K ఫైండ్ అవుట్ చేయాలి అంటే యాక్చువల్గా K ఫార్ములా ఏంటి, K it is equals to 1 by R into L by A. ఈ L by A వాల్యూ రెండిటిదిను సేమ్ అవుతుంది. ఎందుకు, దట్ ఈస్ ఎ సెల్ కాన్స్టెంట్. సరే సేమ్ సెల్ అన్నప్పుడు, సరే ఇక్కడ మెన్షన్ చేశాడు సేమ్ సెల్ వెన్ ఇట్ ఈస్ ఫిల్డ్ విత్, సేమ్ సెల్లే మొలారిటీ చేంజ్ చేసి ఫిల్ చేశారు. సో సేమ్ సెల్ అన్నప్పుడు ఈ వాల్యూ కాన్స్టెంట్ వాల్యూ అవుతుంది. సో L by A it is equals to K into R. Then K value 1.29, then R value 100, then you can get it is 129. Okay, then now sir here conductivity how to find out. Sir ee conductivity ni sir nenu ikkada find out chestha unna, look at ikkada find out chestha. Sir K it is equals to 1 by R into L by A how to take. Sir L by A value the same value how to take. Sir L by A 129, then divided by 520, then you can get it is 0.248, that is K value kabatti sir Siemens, then meter inverse అవుతుంది, meter inverse. So in the place of that you have to substitute the molar conductance, that is 0.248 into, that is 10 to the power of 3, 1000 అంటే 10 to the power of 3. మోలార్ కండక్టెన్స్ ఏం చేసాం, మొలారిటీ ఏం తీసుకోవాలి, 0.02 తీసుకోవాలి సెకండ్ సొల్యూషన్ కాబట్టి. సో దాన్ని 2 into 10 to the power of -2 అని తీసుకోవచ్చా. సో 2ని దీంతో డివైడ్ చేస్తే 0.124 అవుతుందా, ఎస్ 0.124. సార్ వెన్ ఇట్ ఈస్ గో దిస్ సైడ్ పాయింట్ అట్లా పోతే దెన్ 10 to the power of -3, then 10 to the power of +3 cancel, then look at carefully, what is there, 124 into 10 to the power of -2 is there. Are you getting? So now one of the point here, the molarity will be there. So molarity will be there here, that is in the 1000 divided by that centimeter cubes will be there, centimeter cube. దాన్ని మీటర్లో కన్వర్ట్ చేసుకోవాలి. సరే మీటర్లో కన్వర్ట్ చేసుకోవాలంటే 10 to the power of -2, దెన్ మీటర్ హోల్ క్యూబ్ తీసుకోవాలి. సో దాన్ని దీంతో మల్టిప్లై చేయాలి అంటే దెన్ 10 to the power of -6 మీటర్ క్యూబ్, 10 to the power of -6 మీటర్ క్యూబ్. ఇది 10 to the power of -2 పైకి వస్తే ఏమవుతుంది, 10 to the power of +2 అవుతుంది. సో దెన్ యూ కెన్ గెట్ ఇట్ ఈస్ 124 into 10 to the power of -4. So these are the units, you know the molar conductance, right? Molar conductance units ఏంటి, Siemens, then meter square, then mole inverse, meter square, mole inverse, all these units are there here, that is 124 into 10 to the power of -4. This is very important problem, my dear students, you have to note it. Then next one, how does conductivity, conductance, specific conductivity, then molar conductivity, then equivalent conductivity, how does it changes when concentration decreases, nothing but dilution increases. సో నెక్స్ట్ టాపిక్లో మనం దాన్ని డిస్కస్ చేద్దాం. సో ఇక్కడ వరకు అది నోట్ చేయండి. జస్ట్ ఫాలో మై ఛానల్ అండ్ షేర్ ఆల్ ది వీడియోస్ టు యువర్ ఫ్రెండ్స్, దోస్ ఆర్ ప్రిపేరింగ్ ఫర్ JEE mains or those are studying 12th and 11th. So encourage to me. So follow my channel and subscribe my channel.